So good morning to everybody. So today we are going to discuss about the analysis of coal by ultimate method. So first, before going to analysis of coal, first what is the fuel? What is the combustion process? What is the calorific value? We discussed that one. First, fuel. A fuel can be defined as a combustible substance. So means that substance must easily combustible, and fuel mainly containing the carbon and along with the hydrogen, and a large amount of heat will be liberated. That heat is used for the domestic purpose as well as industrial applications. So that is called a fuel. Is a combustion is the chemical reaction between the fuel and oxygen. This is an exothermic reaction because a lot of energy will be released. For example, if you take any fuel in the combustion reaction, react with the oxygen at the higher temperatures, produce the combustion products, along with large amount of heat will be generated. So a fuel must consist of the carbon and hydrogen is the major elements, because the combustion products are coming out from the carbon and hydrogen are carbon dioxide and water vapor. So if these two will be widely used for the environmental recycling. Carbon dioxide will be used for the photosynthesis of the plants, and water will be used for the domestic and industrial applications. If the sulfur present in the fuel, that will be first oxidized to convert the sulfur products. That sulfur products are further converted to the acids, and acid rates will be found. If any fuel consists of the mineral source more, that fuel giving the lot of ash content. So that's why a fuel must have the less mineral content to give the less ash content. So now we can go the coal. Coal is a primary natural fuel. This is the fossil fuel also. This will be obtained in the large accumulation of vegetable debris and alternation of vegetable plants under certain favorable conditions by the action of heat and higher pressures and temperatures over a million years. Not if this process is completed in a single day or single month or single year. It takes millions of years. Coal is mainly composed of containing the carbon, oxygen, hydrogen, along with some quantity of the nitrogen also. So there are two main theories will explain the formation of the coal in the earth crust. First one is the in situ theory, and the second one is the drift theory. According to the in situ theory, the coal formation took place at the same area where the vegetation grew accumulated originally. So in this theory, the great purity of the coal will be appear reasonable on the basis of the whatever plants will be accumulated in the one place. According to the drift theory, so trees when uprooted due to climatic conditions in the deeper parts of the soil and the transformation of coal due to high temperature and pressure, absence of oxygen and presence of bacteria conditions, is a coal will be formed according to the drift theory. So now coming to the coal has been classified in several ways. The most common method for the classification is based on their rank. The first origin of coal, it is clearly from the wood. So first is wood converted to the coal. There are different stages or transformations are there. Is the first stage of coal is the wood, then is the peat, a lignite, a bituminous coal, anthracite coal. So this is the transformation of the wood to coal. That process is called the coalification. So coalification means is that wood is converted to the coal in the higher temperature and higher pressure conditions. There are different transformations of coal is obtaining. Those are the wood, peat, lignite, bituminous coal, anthracite coal. So now coming to these coal calorific values, and now this slide will be showing that one is the coal sample, and what are the coal will be taking from the mines, and these are the some photos of the mines, how coal mines are there, how deep they are going inside, how they taking from the mines. So now what are the different transformations of the coal? The first stage of the coal is the peat. This is the uneconomical fuel and mainly consists of the 80 to 90% of the moisture. If the fuel contain the more moisture content, that will be a less calorific value is giving, because is the more weight is coming, more transportation cost is coming, is the less economical. because it's the more moisture containing. Is the composition of the carbon nearly is the 54 to 57% is there. So that peat is a coal giving the nearly calorific value is the 5,400 kilocalories per kg. Is the second stage of the coal is the lignite, that is also called the brown coal and soft coal. It is the colored lowest rank. Moisture content will be 20 to 60%, and carbon percentage is the 60%, and this type of coal is giving the calorific value is 6,400 to 7,100 kilocalories per kg. Is the third stage of the coal is the bituminous coal. This another name is also called the black or dark colored coal, because it's the very dark color will be there. This coal is largely used in industries for making the metallurgical coke and coal gas formation and domestic heating purpose also. So this is a transformation or this type of composition. Carbon percentage will be 78 to 90% will be there. Volatile matter is the very less, almost is the 20 to 45% will be there, and this will be giving the calorific value 8,000 to 8,500 kilocalories per kg. And the last and most important formation of the coal is the anthracite. This is the highest rank of coal because is the percentage of the carbon will be more. In the percentage of the carbon will be nearly 98% will be there. So this is the very good fuel and giving the large amount of heat. So calorific value also nearly 8,650 to 8,700 calorific value. So carefully observed from the feed to anthracite, the carbon percentage will be decreased and moisture content will be decreased and calorific value will be increased. So carbon percentage will be increased, moisture content will be decreased, and calorific value also increased. Is the last stage of the coal. Anthracite is the best coal and better quality of the coal because the carbon percentage is the more. So coming to the next is that these are the what are the stages involved in the during the wood to coal. These are based on the pressure and the temperature conditions, formation of coal, peat, brown coal, so bituminous coal, and anthracite coal. So now going to the our topic analysis of coal. Is the coal composition varies widely place to place. That's why it's necessary to analyze the coal sample. So which place is good coal sample is there, which place is the poor quality of the sample is there. For that purpose, we must analyze the coal sample. The following methods for the analysis can be utilized for the selection of coal. So first one is the proximate analysis. In the proximate analysis, mainly we record the moisture content, is a volatile matter, how much ash is produced, and finally is the fixed carbon percentage of the original weight of the coal sample taken for the under examination. So in the proximate analysis, mainly give the significances is a commercial classification and industrial utilization of the coal. So coming to the next is the important analysis of coal sample is the ultimate analysis. In this analysis mainly consists of the or determination of the individual elemental percentage, carbon, hydrogen, sulfur, nitrogen, and oxygen. That's why this process is also called the element analysis or ultimate analysis. So now going to the each one by one, we discuss the percentage calculation in the coal sample. So now we discuss about the carbon percentage and hydrogen percentage in the coal sample. So this is the here the diagrammatically showing is that this is the combustion apparatus. Is a combustion apparatus consists of the combustion, whatever is the porcelain board will be taken, is the two U-tubes will be linked, and one is the inlet for the oxygen supplied. So now is going to the procedure is a method for the determination of the carbon and hydrogen. So first we take a known quantity of the dried powdered sample of coal will be taken in the porcelain board in the combustion apparatus. In the combustion kept in combustion apparatus, a pure dry oxygen gas is supplied without moisture and carbon dioxide. When the pure oxygen will be supplied inside, that oxygen will be consumed by the or react with the coal present in the carbon and the hydrogen to convert the carbon dioxide and water vapors. That reactions will be takes place in the next slide. We discuss that one. So when the oxygen will be supplied, if the coal sample will containing the carbon will be converted to the carbon dioxide, and oxygen will be converted to the water vapors. These two gaseous, whatever the obtained the two gaseous mixtures in the combustion apparatus, that will be passed through the first pre-weight. Pre-weight means already take the known quantity of the amount, either calcium chloride in the tube A and the KOH solution will be in the tube B. A known weight of the amount will be taken in the both U-tubes. In the first U-tube will be filled with the anhydrous calcium chloride. Second U-tube will be filled with the KOH solution. Once the carbon dioxide vapors and water vapors passed through this one, is the anhydrous calcium chloride will be absorbed is a completely water vapor to form the calcium chloride water molecule. And similarly, the carbon dioxide will be absorbed by the KOH solution containing the U-tube. So once the already U-tubes consist of the pre-weight we know. So after absorb of the carbon dioxide and water, the weight will be increased. So based on the weight increased, how much carbon dioxide is formed, how much water vapor is formed, we calculate it. So here the reactions takes place according to that one. If coal sample containing the carbon, that will be react with the pure oxygen to convert to the carbon dioxide. Similarly, hydrogen present in the coal sample that will be converted to the oxygen, converted to the water vapor. These two will be absorbed by the KOH, carbon dioxide by the KOH to produce the K2CO3 as a salt, and calcium chloride will absorb the water vapor in the one of the U-tube. The weight increased in the U-tube, one of the U-tube KOH solution, that will be increase the carbon dioxide weight form. And here the calcium chloride U-tube weight increased. That is the indication for the water vapor absorbed. So based on these reactions, the calculation of the percentage in carbon and hydrogen is the weight of the carbon dioxide formed. So how much weight is formed into 12 by 12 into 100 divided by weight of coal sample taken originally into 44. These 12 and 44 are the 12 is the molecular weight of the carbon and 44 is the carbon dioxide molecular weight. Accordingly, hydrogen also is a percentage is calculated based on the formula. Weight of the H2O is formed in KOH bulb into 2 into 100 by weight of coal sample taken into 18. So now coming to the sulfur, how to determine the sulfur percentage in the coal sample. So the principle involved in this one, sulfur present in the coal sample first convert into the oxides, the sulfur dioxide or sulfur dioxide. These two oxides are easily soluble in water and absorb the moisture, converted to the acid of H2SO4. This H2SO4 is further converted to the barium sulfate when treated with the barium chloride. So means here the what is the principle is involved, the whatever sulfur present in the coal sample that will be completely converted into the is the barium sulfate form. So if the based on this concept, how much barium sulfate is formed? So the sulfur present in the calculation, the sulfur present in the coal sample is weight of barium sulfate is formed into 32 into 100 divided by weight of coal sample will be taken in initially into 233. Here the 32 is indicate for the is the sulfur molecular weight and 233 is indicated for the barium sulfate is a molecular weight. Now coming to the nitrogen. So nitrogen determine in the coal sample one of the special apparatus used for this one. That apparatus name is called the Geldol flask. So Geldol flask is simply is a round neck bottom flask and with the long neck will be there. So like in the diagram showing in the long neck will be there. So first is the dried coal sample will be taken in the Geldol flask and concentrated sulfuric acid will be added and potassium sulfate as a catalyst. In this condition, whatever nitrogen present in the coal sample first react with the sulfuric acid under the heating conditions to convert it to the ammonium sulfate. So means here the whatever nitrogen present in the coal sample first stage converted into the ammonium sulfate form. Then this ammonium sulfate is further treatment with the alkali or sodium hydroxide in the under the heating conditions to produce the ammonia gas. So means nitrogen is completely converted in the form of ammonia gas. So this ammonia gas is passed through the known and standard, known quantity and known volume and standard of acid solution containing the volumetric flask. So this ammonia gas is passed through the in the volumetric flask containing the known volume and standard concentration. So once the ammonia gas will be passed, this will be react with the some of the acid will be consumed to produce the ammonium chloride. But unused, unreacted HCl, whatever acid, that will be further determined by back titration with the sodium hydroxide solution using the phenolphthalein indicator. So means this will be indicating that how much acid will be consumed for the ammonia gas. So how much ammonia is consumed for the acid from the solution. So based on these reactions, we calculate the percentage of the nitrogen in the cold sample is the volume of the acid will be consumed for the ammonia and the normality of the acid into 1.4 divided by weight of cold sample will be taken. Or another formula used for that one, volume of acid will be used and change in normality of acid. Change of normality of acid means in the sense of the before ammonia gas is passed through the acid solution, how much normality is there? After passing the ammonia gas into the acid solution, how much normality will be changed? Because here the sum of the ammonia will be react with the acid solution, so the normality will be changed. So into 1.4 divided by weight of cold sample will be taken. So using these formulas, how much nitrogen percentage in the cold sample will be determined. So the last element is the oxygen. The percentage of oxygen will be calculated is a subtracting of the all elemental percentage. For example, percentage of oxygen is equal to 100 minus percentage of carbon, hydrogen, nitrogen, and sulfur. These are all percentage will be subtracted from the 100. You get the oxygen percentage. So now go for the significances of the ultimate analysis. So means what is the importance of the ultimate analysis? First one, if the carbon and hydrogen percentage is a more hydrogen carbon percentage in the fuel, that is the better quality of the fuel and giving the more calorific value. If second one is a nitrogen, if nitrogen present in the cold sample, that does not any improve the calorific value, because is a nitrogen almost will be as an inert gas. So only weight will be increased. So for weight calculation, so we can determine the nitrogen also. Sulfur, if sulfur present in the cold sample, the calorific value will be increased. Calorific value is increased. But the disadvantages is there if the sulfur present in the cold sample. When the sulfur is converted to the oxides of sulfur dioxide or sulfur dioxide, that oxides once again consume the water or moisture to convert it to the acid. That acid is a corrosive effect on the combustion apparatus or furnace. Is a fourth one is if oxygen, more oxygen present in the cold sample, in the that will be combined with the moisture, causes of the low calorific value. Simply say is the more oxygen percentage in the cold sample, that calorific value will be decreases. If 1% of the oxygen present in the cold sample, the calorific value almost is the 1.7% is a decreases. These are four of the significances of the ultimate analysis. Thank you.